Good morning. Myself Yasodha. I am working as an assistant professor in SNS College of Engineering. Today we'll discuss about introduction to integration. The relationship involving the rate of change of two variables, but also needed to know the direct relationship between the two variables. For example, we may know the velocity of an object at a particular time, but we may want to know the position of the object at that time. To find this direct relationship, we need to use the process which is opposite to differentiation, that is called integration or anti-differentiation. So next, importance of integration in mathematics. So we are using integration to find the area, and in physics we are using integration to find the displacement, velocity and acceleration. Engineers utilize integration for solving various real-world problems involving optimization and design. Economics and finance. Integration is essential in economic analysis and financial modeling for understanding change over time. Next, types of integrals. There are mainly, we use two forms of the integrals. One is definite integrals, an integral of a function with limits of integration as the definite integral, and in infinite integrals, it is an integral of a function when there is no limit for integration. It contains an arbitrary constant. And one more, improper integral. It addresses integrals with infinite limits or discontinuous integrands. Next, basic integration rules. The integral rules are used to perform the integral easily. It is used to integrate different types of functions. First, if the function is in the form of addition or subtraction, we use the linearity rules. If the function is power function, then we can use the power rule. When the function is difficult, and we use substitution method to solve very easily. Next, techniques of integration. We are using many techniques for integration. First, integration by trigonometric substitution utilizes trigonometric identities to solve integrals. Partial fraction. It breaks down rational functions into simpler integrable parts. Third one, integration by parts. In this, technique is based on the product rule of differentiation. Next, integration by substitution. In this method, first one, change of variable method. It involves substituting a new variable to simplify complex integrals. Then, integration factor. In this method, used to express complex integrals in terms of simpler ones. Third one, application in multiple dimensions. Applicable for solving multiple integrals in higher dimensions. Next, integration by parts. In this method, it is used for integrating the product of two functions. This method is used to find the integrals by reducing them into standard forms. For example, if we have to find the integration of x into sin x, then we need to use this integration by parts method. The integrand is the product of two functions. Next, integration of trigonometric functions. Sine and cosine integrals. In this method, special techniques are used to integrate sine and cosine functions. Similarly, for tangent and secant integrals, specific substitutions are applied for integrating tangent and secant functions. Some of the applications of integrations are given. First one, area under curves. Used in physics to find work done and elastic potential energy. Second, volume of solids. Applied in engineering for calculating precise volumes of complex shapes. Next, population growth models. Utilized in biology and social sciences to study population dynamics. Conclusion. Integration is a mathematical technique to calculate the area under a curve. There are multiple methods for integration. Thank you.